Hello everyone, welcome back to another video. So today we will discuss solutions for biweekly contest 122. I was able to solve all 4 problems, so this will contain solutions for all 4 problems. So let's just start with first problem. So first problem, we are given in this problem. Let me just. So in this problem, we are given an integer array of length n, and we have to divide this array into 3 disjoint contiguous subarrays such that the sum of starting element of all subarrays is minimum. For example, in this case 1 to 3, the cost of such array is 1 because the first element of array is 1. Similarly, cost of this array is 3 because first element is 3. Now we have to divide the whole array into 3 contiguous subarrays, and the cost of all total cost sum of total cost of all subarrays should be minimum. For example, 1 2 3 12, we can divide them into such partition, and the cost here will be 6 because 1 plus 2 plus 3, and it is minimum. There are also other ways, but the cost here is greater than 6. Similarly, here the answer is 12, and here answer is again 12 with this kind of division. So this is pretty simple problem, because constraints are very low, and if constraints are also higher like 1e5, n log n solution also works with multiset. So let's just see brute force for it. A1, A2, A3 up to an. So this first cost will always be there whatever division you make. So A1 will always be included in our answer. Now other possible options are, let's make start of second subarray A2. Then this we have to add A2 to the total cost, and then from A3 to AN we can take any minimum element, such as, let's say, AK is the minimum from 3 to n. Now this is the one of the possible cost. Now second possible cost is A1 will always be there, but we make start of second subarray as A3. Then again third element can be minimum element from A4 to n. This is another possible combination. Now another possible combination can be A1 plus we will make start of second subarray as fourth element and take the minimum element from fifth to n. So we have to do this until n minus 1 and take minimum answer out of it. So we can do it by brute force. So for example, I will start from 1 to n minus 1, and I have some declared sum as int max and answer as a of 0. Now I will take minimum element from j I plus 1 to n and add it to ai and calculate minimum value of ai plus mx, that is ai plus minimum element to its right side, and finally just return answer plus sum. Answer is a of 0, which is all we have to add always, because first element will always contribute to total cost. So this is pretty simple, and fourth question is just second part of it, but it has some additional conditions, so we will see it after second and third. So second question was about swapping and making the array sorted. So we have given a condition that we can swap at any two adjacent elements if they have same number of bits. The same number of set bits means the number of set bits, number of ones in its binary representation should be same, and we are allowed to do this operation any number of times, and we have to return true if we can sort the array or else return false. So for example here 842 30 50, 842 have 1 bit set in it, so we can swap in this sub array and make them 248, and 30 and 15 have around 8 16 plus 8 plus 4 set bits in both of them, so we can just swap them, so it becomes 2 4 8 15 and 30. So the array becomes sorted. Similarly here it is not possible. So let's take this example. Let's just start with the base case. Let's say I have an array of all of them equal to all the elements have set bit equal number of times, means this kind of array of size 5, and all the elements have one only one of the bits is set in each of the element. So here 16 to 4 8 and 32. Now this array can always be sorted, because that's the logic of bubble sort. We can just swap the minimum element until it reaches its position in sorted array. For example, swap this to here, so it becomes 2 16 4 8 32. Then again swap this 4 to its original position, 2 4 16 8 32, and again swap this. So this is just a bubble sort logic. So we can sort all the elements because uh, all the elements have had equal number of bits, z bits. Now what if there are like this, when all elements doesn't have, for example 8 4 2 30 and 15. This part of this subarray can be sorted separately. This subarray can be sorted separately. So based on a number of set bits of current element, we have to make partitions of the array and sort each of them separately. So I will sort this separately 2 4 8. I will sort this separately 15 80 30. If there was another partition, I will sort them and append it here. And after finding this uh, array, we have to just check if the whole array is sorted or not. If it is sorted, we return true. If it is not, we return false. So it's a simple implementation. So first I declared a current which is current integer variable, so which is the number of set bits in first element, and I have two vectors, answer and res. So answer is temporary vector, res is final vector, and I will push a of 0 into answer. Now if the I will start iterating from 1 to n and calculate d, which is number of set bits in AI. If it is equal to d current, I will just push it into temporary vector, and if they are not equal, I will just sort the temporary vector and push all the elements from temporary vector to final vector, and make just clear the temporary vector and push a of I and make current equal to the number of set bits in that ith element. Similarly, we have to do this at the end of our for loop, because if this condition is not matched, we don't add any elements from the answer, and this for loop is just to check if the array is sorted. If I found this type of condition, I will just return false, else I will return true. So this was also pretty simple question, just uh, more implementation than first one. So third question. So in this question we are given an integer array of positive integers, and we can perform this kind of operation where we choose I and j and nums of I is greater than 0, nums of j is greater than 0, and we insert nums of I mod nums of j at the end of nums and delete all the elements from delete the elements at indices I and j. We have to perform this type of operation any number of times and return the minimum length of the integer array. For example, here I will just take 3 and 4, so array becomes 1 1 3, then 1 and 3, then 1 1, and finally 0. So length of nums is 1. So main observation is to just sort the array, or you can say if I take mod of x and y, where x is less than y, the y gets eliminated from the array. So x mod y will always be equal to x because x is less than y. So I delete x, I delete y, but inside x, so x remains in the array, but y gets eliminated. So we just need to eliminate all the elements. So if we eliminate the max element first, we keep eliminating max element from the array, and finally we just return whatever size we have. Now there is also one edge case. Let's just first see this kind of simulation on possible arrays. For example, 5 5 5 and 10. Now using this 5 we can eliminate this 10, and when the elements are all equal, then we have to return let's say occurrence of minimum elements are m, then we have to return m by 2 plus m mod 2, because for 5 here I can eliminate this 2 5s and make 0, eliminate this 2 and make 0, but if there was an additional 5 I cannot do anything with it, so I just have to keep it. So here answer becomes 3, so m by 2 plus m mod 2. But what if I had an array something like this: 5 5 5 5 and 6. Now what I can do here is I can take 6 mod 5 and insert it, so array becomes 1 5 5 and 5, and using this one I can eliminate all these 5s. So if we can if the occurrence of minimum element is greater than 1, so we have to check if there is any possibility to generate a smaller element than this 5, and if there is some possibility we will just generate it. It can be 1 to 4, means 1 to any smaller element than 5, and 0 is not acceptable because this condition nums of I greater than 0, and we will generate this one, and using that number we will eliminate all the maximum integers. So in this case answer becomes 1. And now if there are no possible ways to generate 1 to m minus 1, for example here 5 5 5 5 10, because GCD of 5 and 10 is not equal to 1, then there is no option, we just have to take answer from this minimum occurrence of minimum elements itself. There is no other option, so we have to basically do this. And because of these edge cases only, a lot of people got wrong answer penalties, but I use this GCD kind of approach. So I calculated GCD, and GCD will return 1 if there are no GCD will, and then GCD will basically return minimum element or 1. So minimum element, because if all of them are multiple of let's say 5 10 something like that, so it will just return calculate GCD, and calculate the occurrence of that GCD. Now if the occurrence of that GCD is 0, like this 234, here GCD is 1 and occurrence of that number is 0, but I can generate 1 using 3 and 2, or I can generate any smaller element than first element. So I will just return 1 in that case, else I will just return mx by 2 plus mx mod 2, or also you can write mx plus 1 by 2. It's basically the same. So this was the third question, and now we'll see fourth question. Fourth question I think is easier than this. Number doesn't justify the difficulty of this. This is, if this question comes on code forces, a lot of people will solve this kind of question because it's easy. It's very easy to think of its solution. So you just see. So this is just second part of this question, but here we have to divide the whole array into k contiguous subarrays, and also an additional condition is given that the start of second subarray and the start of last kth subarray, so the distance between both of them should be less than equal to dist. So distance between them is just absolute difference of the indices, and it should be less than dist. So a1, a2 up to an. Now so again a1 is always fixed. Now the condition given to us is start of second subarray and kth subarray. So we obviously we have to iterate for the second start of second subarray from a2, a3 up to whatever possible, probably a n minus k plus 2, something like that. So till here it will be possible, after that it will not be possible. And we have to just iterate for check answers for each of these elements and take minimum of it. And how to do it? So we know first element, we know we have fixed start of second subarray. Now we have to take k minus 2 minimum elements from right side of it, and this sliding window has a fixed size. So if we start from 2, the sliding window will start from 2 plus 1, which is 3, up to 2 plus dist. So to satisfy the dist condition, so this is the sliding window size. And for maintaining the k minus 2 minimum elements, we can use set. So I will just generate a set of sliding window, and whenever I move to right, I will delete the leftmost element. For example, when I am moving from a2 to a3, I will delete this a2 and insert a of 2 plus dist plus 1. So a of 3 plus dist, I will insert it into set. And for calculating k minus 2, I can't iterate every time from the set. So for that I have divided the original set into two sets. One is original set itself and another is used. Now first I will generate original set at the start of iteration, means before starting iterating from a2. I will generate this set st and take k minus 2 elements in used set. Now whenever I am iterating, going from left to right, means changing the sliding window size, I will, if the element which is uh, element which I have to remove, I will check if it is in used, or if it is in st I will remove it. and I will insert that element in next rightmost element which is needed to insert. I will insert it in st. Now if use.size becomes less than k minus 2, I will take the minimum element from st and insert it in used set. And also I have to check if the maximum element from used set is greater than minimum element of no, unused set. I can swap those two elements. So this is basically the logic, and it is not that hard, but implementation is kind of big. But if you understand the solution, implementation will be very easy. So I will just explain implementation. So I first created the normal set st from 2 to 1 plus 2 plus dist and minimum of both of them. And so this is just creating the sliding initial sliding window set, and I will take minimum of first k minus 2 elements from original set and insert in used set, and also calculate the sum for it. So this sum is initial answer, and whenever I'm moving from I to I plus 1, sorry, I minus 1 to I will subtract a of I minus 1 from sum, add a of I, and if I will erase that element if it is found in st. If it is found in used, I have to also subtract its value from sum, and again I will insert the rightmost element, which is I plus dist. And for or segmentation fault, I have to just add this condition. And if use sort size becomes k less than k minus 2, I will insert minimum element, add that into sum. And this type of condition, if the maximum element of used is greater than minimum element of st, so I will just swap them. Now this will not run no more than, so this will run only for at most twice. I don't think at most twice, because I'm just changing the set only by two elements, so I'm removing one element and adding another element. So this change is at most 2, so this will, why this while loop also will run at most twice. So it's just similar to 2 into n into log n type of complexity. So this works, doesn't give TLE, and but implementation is difficult. So if you understand this logic, try to write the code by yourself instead of seeing this.